The universe is a dynamic, ever-evolving entity. It's a vast, almost incomprehensible expanse that is constantly changing and transforming. From the smallest particles to the largest galaxies, everything is in motion, contributing to the grand cosmic dance. One of its most mind-boggling aspects is its expansion. This phenomenon is not just a simple movement of objects within the universe, but a fundamental stretching of the very fabric of space itself. This isn't the expansion of objects within the universe, but rather the stretching of space itself. Imagine the space between galaxies growing larger, not because the galaxies are moving through space, but because the space itself is expanding. Imagine dots on a balloon. This analogy helps us visualize the concept more clearly. As you inflate the balloon, the dots move farther apart, not because they're moving across the balloon's surface, but because the surface itself is expanding. This is similar to how galaxies move apart as the universe expands. This concept of an expanding universe might seem strange at first. It's a challenging idea to grasp because it defies our everyday experiences and intuition. After all, we're used to things having boundaries. We think of objects as existing within a defined space with clear edges and limits. We think of expansion as something moving outward into a pre-existing space. But the universe's expansion is different. It's the space itself that is growing. However, the universe challenges our everyday intuition. It forces us to rethink our understanding of space-time and the very nature of reality. The first hints of this cosmic expansion emerged in the 1920s. During this period, astronomers began to notice peculiar patterns in the movement of distant celestial objects. Astronomer Edwin Hubble made a groundbreaking discovery: distant galaxies were receding from us. This observation was revolutionary and changed our understanding of the cosmos. Moreover, the farther away a galaxy was, the faster it seemed to be moving away. This relationship between distance and speed was a crucial piece of the puzzle. This observation, now known as Hubble's law, provided the first concrete evidence for an expanding universe. It showed that the universe was not static, but dynamic and ever-changing, constantly growing and evolving. Hubble's discovery laid the groundwork for the Big Bang theory, which posits that the universe began as a singular, incredibly dense point and has been expanding ever since. This theory has become a cornerstone of modern cosmology. Today, scientists continue to study the expansion of the universe, using advanced telescopes and observatories to gather more data and refine our understanding. Each new discovery brings us closer to unraveling the mysteries of the cosmos. One of the most intriguing aspects of this expansion is the role of dark energy, a mysterious force that seems to be driving the acceleration of the universe's growth. Understanding dark energy is one of the biggest challenges in modern physics. As we continue to explore the universe, we uncover more about its structure and the forces that shape it. The cosmic web, a vast network of galaxies connected by filaments, is a testament to the complexity and beauty of the universe. The journey to suggested that the universe was not static and unchanging as previously thought. Instead, it was dynamic and expanding. Imagine you're standing still and everything around you is moving away. Objects closer to you seem to move slowly, while those farther away zip away at incredible speeds. This is similar to what astronomers observed with galaxies. The farther a galaxy is from us, the faster it recedes. This observation is a key piece of evidence for the expanding universe. It tells us that space itself is stretching, carrying galaxies along with it. This concept is fundamentally different from objects moving through space. It's crucial to understand that the expansion of the universe isn't like an explosion, where objects are flung outward from a central point. Instead, it's the fabric of space itself that's stretching. This stretching carries galaxies along for the ride. Imagine a loaf of raisin bread dough rising in the oven. The raisins represent galaxies and the dough represents space. As the dough expands, the raisins move farther apart. However, the raisins themselves aren't expanding, they're simply being carried along by the expanding dough. This analogy helps illustrate how the expansion of the universe affects the distances between galaxies. The galaxies themselves aren't moving through space, they're being carried along by the expansion of space itself. Section 4. The balloon analogy. Another helpful analogy for visualizing the expanding universe is the balloon analogy. This simple yet powerful analogy helps us grasp the concept of how galaxies move apart as the universe expands. Imagine a balloon with dots drawn on its surface. These dots represent galaxies scattered throughout the universe. Each dot represents a galaxy. As the balloon inflates, these dots or galaxies move away from each other. As you inflate the balloon, the dots move farther apart. This movement is akin to how galaxies drift apart in the expanding universe. The farther apart two dots are, the faster they appear to move away from each other. This is similar to how galaxies that are farther apart in the universe seem to recede from each other more quickly. This analogy highlights two key points about the expanding universe. First, it shows that the expansion is uniform and isotropic, meaning it looks the same in every direction. First, there's no center of the expansion on the balloon's surface. No matter where you are on the balloon, the expansion looks the same. Similarly, there's no center of the universe's expansion within our three-dimensional space. Every point in the universe is moving away from every other point. Second, the expansion is happening everywhere in the universe simultaneously. This means that no matter where you are in the universe, you will observe galaxies moving away from you. Every point in space is moving away from every other point, just like every point on the balloon's surface moves away from every other point as the balloon inflates. This helps us understand that the universe is expanding uniformly. This analogy has its limitations, of course. While it helps us visualize the expansion, it doesn't capture all the complexities of the universe. The balloon is a two-dimensional surface embedded in three-dimensional space, while the universe is thought to be at least three-dimensional. This means that the analogy is a simplification. However, the balloon analogy provides a useful tool for visualizing the basic concept of an expanding universe. It helps us grasp the idea that the universe is not static but is constantly growing, with galaxies moving away from each other over time. This analogy also ties into the Big Bang theory, which suggests that the universe began from an extremely hot and dense state and has been expanding ever since. Just as the balloon starts small and grows larger, the universe has been expanding from its initial state. The cosmic microwave background radiation was another piece of evidence supporting the expanding universe. This radiation is the afterglow of the Big Bang and can be observed in every direction, further confirming that the universe is expanding uniformly. Over billions of years, the universe has continued to expand, leading to the vast cosmos we observe today. The balloon analogy, despite its simplicity, helps us understand this grand and ongoing process. So, next time you look up at the night sky, remember the balloon analogy. It's a simple yet profound way to comprehend the ever-expanding universe we are a part of. Section 5. The Big Bang, a starting point, not a location. The expansion of the universe implies that it was once much smaller and denser than it is today. This leads to the concept of the Big Bang, the event that marked the beginning of our universe as we know it. The Big Bang wasn't an explosion in pre-existing space, as the term might suggest. Instead, it was the beginning of space and time themselves. It's more accurate to think of the Big Bang as a rapid expansion of space from an extremely hot, dense state. The Big Bang theory doesn't tell us what caused the universe to begin expanding. It simply describes the early universe's evolution based on our current understanding of physics. However, the evidence for the Big Bang is overwhelming. From the cosmic microwave background radiation to the abundance of light elements in the universe. Section 6. Into the unknown, what lies beyond? The question of what the universe is expanding into is a natural one to ask. It's a question that has puzzled scientists and philosophers alike for centuries. However, it's based on our everyday experience with objects expanding into a surrounding space. We are used to seeing things like balloons or soap bubbles grow larger within a room or an open area. This intuition doesn't apply to the universe as a whole. The universe operates on principles that are far beyond our everyday experiences and common sense. The universe isn't expanding into anything outside of itself. This might seem counterintuitive, but it's a fundamental aspect of cosmology. This is because the universe, by definition, encompasses everything that exists. There is no outside to the universe, it is all-encompassing. There's no outside for it to expand into. The concept of outside simply doesn't apply when we talk about the universe. Imagine you're a two-dimensional being living on the surface of a balloon. Your entire existence is confined to that surface. As the balloon inflates, your two-dimensional universe expands. The dots on the balloon move further apart, but they don't move into a pre-existing space. However, you wouldn't expand into a pre-existing two-dimensional space. Your universe is self-contained on the surface of the balloon. You would simply experience your universe getting bigger. The distances between points in your universe would increase, but there would be no outside to move into. The universe's expansion is a mind-bending concept. It challenges our everyday intuitions. It requires us to think beyond our usual experiences and consider the nature of space and time itself. However, by carefully considering the evidence and using analogies to guide our understanding, we can begin to grasp the awe-inspiring nature of our expanding cosmos. The universe is a vast, dynamic entity, constantly evolving and expanding, and our journey to understand it is just beginning. As we continue to explore and learn, we may uncover even more astonishing truths about the nature of our universe and what lies beyond. The quest for knowledge is endless, and the mysteries of the cosmos are waiting to be unraveled. With each discovery, we take one step closer to understanding the grand tapestry of existence. The universe, in all its complexity and wonder, invites us to keep asking questions and seeking answers. From the moment of the Big Bang to the ever-expanding cosmos we observe today, the story of the universe is one of constant change and growth. And as we look to the stars, we are reminded of our place in this magnificent, ever-expanding